Hey, welcome to another practice question review video. That's me trying out my Korean language letter pronunciations. Because now that I've fully finished my deepest work with this new CCSP course, I can go back to the things I was doing before May 2023 when I first started. When I first started this course from scratch, guys, from scratch. The pre-launch last week brought in over 100 students, and I'd like to just read this really nice email I got from one of those students. Hey Luke, the CCSP course is really perfect. Okay, at least the first two domains that I have seen, smiley face. I can compare it with the official IC squared self-paced training. Yours is much better. You don't really have to say that. I'm not trying to be compared to anything else, but I appreciate it. I do appreciate that. And he goes on to say, I hope that it will be helpful in the same way as your CCSP course I bought 3 years ago. That's a crazy thing with the CCSP course launch last week. It brought out all those that I helped in their CCSP studies with my CCSP course, like people from 2, 3, 4, and 5 years ago, or however long 2017 was. Don't tell me that was 6 years ago, was it? Let's see. Let me do the math. 2017, so plus 3 is 2020, so that's 3 years. Plus 4 is 2024. 7. Yeah, 7 years ago. I haven't heard from these guys from 7 years, and they hit me up. And if you're watching this video, whoever sent me this email, thank you for the email. It feels more like a giant relief than it does satisfaction. A relief that 10 months of hard work didn't go to waste. Phew. All right, now on to the practice question found in the course, along with 300 other questions with full explanations. Here we go. We've all heard of securing data at rest with symmetric encryption algorithms like AES-256, as well as securing data in motion with TLS or IPsec VPNs, and the more traditional way to secure data in use, which is through tight access control, least privilege, or other administrative restrictions. But now the CCSP syllabus provides us an actual technical implementation of securing data in use, not just through access control. Which of the following choices secures data privacy while it is being processed by the system's CPU? Is it choice A, fog nodes? Is it choice B, ephemeral computing? Or is it choice C, containerization? Or is it choice D, trusted execution environment? For choice A, fog nodes are computing devices deployed at the edge of the network to perform processing tasks and store data locally. Okay, here's a quick explanation about fog nodes from my CCSP course. If the owner of this agricultural field were to use edge computing, the smart sprinklers would make autonomous decisions about when and how much water to dispense based on the locally collected data, meaning these decisions are made in real time at the edge without needing to transmit data to a centralized server or cloud platform, enabling rapid response to the changing conditions and reducing the latency. Instead of data being sent to the cloud all the time, far away from the farm, instead there are remote sensors available locally that will do all the processing and computing, before sending it to the cloud for secondary processing. What I'm saying is, edge computing involves deploying computing resources such as small-scale or big-time servers or processing units closer to where data is generated or consumed, often at the, you could say, edge of the network. By placing computing resources closer to the data source, edge computing reduces the physical distance that data needs to travel, thereby reducing transmission latency. Edge computing devices have the capability to process data locally without needing to send it to a centralized data center or cloud server for processing. The local processing capability allows edge devices to analyze and respond to data in real time, without the delays associated with transmitting data over long distances to centralized servers. And fog computing is similar. But instead of the remote units doing the processing, there are separate gateway devices that collect the data and performance and correlate that data centrally. Look, I'll be honest with you. I don't really have any experience with this stuff, but I think the gist of it is, in edge computing, the remote devices do the processing. In fog computing, different things called fog nodes do processing centrally, but still remotely and closer to the source of the data, not all the way out to the cloud. For choice B, these are temporary servers created for serverless technology or on-demand computing. On-demand computing is a cloud security. It's a cloud shared consideration. You gotta know. You gotta know about on-demand computing if you're gonna pass the CCSP exam. You gotta know about all the cloud shared considerations for the CCSP exam if you want to pass that exam. Okay, that's like a basic thing you have to know. And here's another quick explanation of ephemeral computing from the course. This is why good grammar is important, guys. Because when you write a script, you want to use good grammar. So instead of, when I wrote it, I wrote I.T instead of it. I wrote IT as an IT. You know what I mean? So grammar helps if you're ever going to write a script and do stuff like this. And ephemeral computing refers to the concept of temporary or short-lived computing resources that are created dynamically to fulfill specific tasks or workloads and are then disposed of once their purpose is served. This also goes in line with the CCSP topic of just-in-time computing. And lastly, serverless technology as an emerging technology. This refers to a cloud computing model where cloud providers And for choice C, if you need a way to package, deploy, and manage applications through Docker, then you use containerization. A container has all the utilities and file types to run applications within itself, and then can be opened on another operating system. It's not a way to secure data in use. And I would share my video about this from the course, but this topic is way too big to talk about in this video. But the definition that I just provided should give you a good idea. And for choice D, a trusted execution environment is used in confidential computing. It is a secure and isolated execution environment within the CPU that ensures the confidentiality and integrity of code and data during execution. Okay. First, the processor conducts an assessment of the firmware's integrity, guaranteeing a secure and measured boot process before initiating operations. And then second, the processor creates a segregated trusted execution environment, otherwise known as a TEE, which is distinct from the system itself, where the user's application operates securely. Then the application loads encrypted data into the TEE, decrypts it, executes the user's program, encrypts the resulting data, and then transmits it. It's pretty amazing. It's pretty amazing. Like, even for the CCSP course, this is good to know, because we know how to secure data at rest. We know how to secure data in motion. And with data in use, we're like, well, how are you going to encrypt live data, data being used in real time in a production environment? And now we have that solution, which is choice D, trusted execution environment. Now you can tell all your friends you know a way to secure data in use at a technical level, not just an administrative level. Okay? The correct answer is D. Take care, guys. You got this, and I hope you sign up for my CCSP course.